Here we stop. This is from part 2, and we stop here yesterday. So we'll continue here, and inshallah we'll continue, and we'll cover part 2 inshallah today. So we are talking about data representation. So the one way to represent the structured data is in the form of tables. We all know that a table represents a structured data. Okay. It also a table represents a data as well as the metadata. We talked about metadata before. Metadata is nothing but data about the data. So for in any table, if you see a table has rows and columns. So and there is a table name, fine. So a table name is a data about the table, which is metadata. Column names, column headings, okay, or the metadata. So data will the table or the data in a tabular form will contain data as well as metadata. Okay, so it is structured into rows and columns. Tabular data is the data that is structured into rows, each of which contain information about something. That is, one row will contain information about one object. So if you, for example, if I draw a table of students, okay, to record the student ID, student name, and all, so it can be in a form of tables in this way. Just let me draw this for you. So if we talk about the table, then we'll draw the table here, for example. So let's say that we draw a table here. So every table will draw some columns, okay, and rows, fine. So a table has rows and columns. Okay, so every row here will be like every row here will be what will be a record of a student. Okay, for example, here it is student ID, for example, and here it is a student name, and here it is, for example, a student email. Okay, here is its, for example, mobile number. Okay, and here, sorry. And here might be let's say address, right? So every row here will represent one student. For example, student ID 12345, name Ahmed, email ahmed at gmail.com, and mobile number 123456, address XYZ. So one student record in one row, that is, it represents one object. Okay, so the data in the form of table will be represented in a form of, okay, rows, okay, which contain information about something or object. Each row contains same number of cells, okay, which provide the value properties of that object. In the tabular data, cells with the same column provide value for the same property described by a particular row. So every column has a value of the same type of value. Okay, so for every object, it provides the value. So according to W3C model, a table must contain at least one column and one row. Then it is called as a table. We see worksheet, spreadsheet to use worksheet or for two-dimensional cell-based tabular data display, that is Excel sheets, and we can also draw the tables and all. So just we draw the table in the Word file. So the same we can have in different applications. We can draw the tables to record the data. So you can see the table with a title here. So here the title is the metadata. The column names is the metadata for the column. So you say that every row here, this is one row represents data, fine. Another row represents the state of Skoda. Third row represents the score data of Ford. Okay. So you can say a make will have, this column will have similar values, that is only the makes. This column will have the similar value, that is the models. This column will have only colors. This column will have only registration number, similarly mileage, similarly price. Okay, so you can see that each cell in the make model column must contain a string. Okay, color is a string, registration alphanumeric, mileage numeric, price is numeric, right? So this is how the data can be represented in a form of tables. Okay, so here again metadata used to group the columns, forming an hierarchy. Okay, vehicle details and sold, fine, both two. So for example, this is the sale data. This data is for sales. Okay, and this data is vehicle. This is vehicle data, right? So this vehicle data, this is sale data. Okay, so the overall is the car sold. What is the car detail? So this is again a grouping of data in a form of tables. Fine. So this is how we can represent the data in a form of tables, the structured data. Move ahead, logical presentation and physical representation. From the point of view of data managers and other users, a tool that is called a DBMS or a database management system, the data is presented in the form of table. However, the data is actually represented on a physical machine. Okay, the data that appears as a table will be stored in the form of indexed file or arrays in a physical device that is inside a computer. Inside a computer, inside the physical device, or for example, inside the system, it is not stored as a table, but it is as a arrays or an index file. Okay, for us, how we see the data is in a form of table. It is presented in a form of table, but physically inside the machine, it is stored in the form of index file or arrays. So you can see that the data logically how we represent the data. For example, if this is a car data in real world, this will be represented in a form of tables. Okay, and then when we save these tables inside the system, how these inside the system it is been stored. It is been stored in a form of index files or arrays. Okay, so this is a DBMS software, data handling or data management software, that converts that index file and represent on the screen the data in a form of table. Okay, okay, representing tables in a web pages. If you want to include those tables in a web page and display those tables in a web page, it is very simple and easy. Using HTML, you can do that. Okay, HTML provides a tag called element, provides an element called table element. Okay, that help you to draw the table. You can explore this and see what is a table element and how we can use this table element in the HTML. Also we can do that in XML. Okay, also we can represent the data as a table in as a JavaScript object for manipulating the tables. Okay, so a JavaScript object can also be used to store the table data as a object and use that JavaScript object to display that in a web page. Fine. So there are tools available that how we can represent the data in a uh, in a web page, on a web page. Okay. Fine. Document data, that is another form of representing the structured data, is documents. Fine. Data scientists refer to a document as any file or representation that embodies particular data records. So books are usually divided into chapters and sections. They contain illustration, footnote, endnotes, tables, index ending, all. They all employ single typeface, or a variety of typefaces. So we can look this first as a structured data, okay, that it is arranged in some structure. For example, in the form of chapters, and every chapter in a form of headings and paragraphs, okay. This is a clear arrangement of data. So that is again a structured data, fine. So how we can store that? We can use some markup language like XML or HTML to capture that in a form of tables. Okay, the best markup language we can use is an HTML language. HTML provides us different ways that we can arrange the data, that like what we have seen in a form of tables or as a documents. Okay, just a minute. Prayer call here. Okay. So the other way that we can represent the data as a structured data in a form of documents using the markup languages, whether you can use HTML as markup language to represent the data, or you can also use XML, okay, to represent the data in a form of to represent the structured data. Using HTML, you can just see the data in a form of table, okay, on a web page, or you can also arrange the data in a form of like a book, okay, where you can have a headings, title, headings, okay, paragraph and all. Okay, you can add paragraphs, you can add as a heading, you can add as a title, you can add the title and all. Okay, so you can have a title there, you can include a title in your HTML web page. You can include headings by using H1, H2, H3. So you have a heading from H1, H2, H3, and so on. So the headings might be like in the form of right, right. Let's see. Yeah. So we have H1. It is just dots. Can I draw the lines? No. I think no, I cannot use it. Anyway, let's use this. Right. So we can have in the form of table. So heading can be in a H1 with a big heading, H2 with a bit smaller and smaller. From H1 to H6, you can have different size of headings. Okay, you can add the titles, you can add paragraphs. Okay, you can make the text bold, you can make the text italic. Fine. So all this possible, and you can structure the data on a web page using the HTML. So you can see here, for example, the title is added here. Fine. Then a heading is added here with the background color. You can change the color, style sheets. Then we have a table with width 100% background color. We have a table row where we have the life and the death of Julius Caesar. Then we have another row. It has a link, okay, an anchor tag. Fine. So this is one complete table with 3 rows we have here. Fine. uh, no, 2 rows we here we have with 2 columns, right, with 1 column, 2 rows with 1 column. Okay. Similarly, headings can be used with H3 or or H1, H2, H3. Fine. You can make the text italic. You can also make the text bold. Okay, underline. All this possible. Okay. Uh, when is the basic markup is not sufficient, if it is having a very huge data to be represented, then we can, it's not sufficient to use this basic markup language. Okay, for a simple paragraphs and all, it's okay, but if you have a huge data, then it may not be suitable. You might need to write many tags, you might need to write too many tags and too many text. Right. Also, if you want to process this data, you want to take this data into another file, or you want to send this data from one computer to another computer or one system to another system, you cannot send it as a HTML file. Okay, and you cannot pass it in a HTML file. So we can need to use tools like XML. The XML will represent the data, which can be used to processing the data, which can be used to process the data. XML is nothing but extended markup language. It represents arbitrary data structure. It is easy for both humans and machine readable. Fine. Easily we can write both human and machine readable. So you can see that data in a form of XML. Okay, and XML. So you can see the titles here. So this represent a title. This represent a car. Okay, so car has a make, and it has a model, registration, and a price. So this is one record of car. Another car here, fine. It has a make, registration, price, and model. This is another car. So you see that the cars are represented in a structured way. in a structured data using an XML, and these XML files can be processed, can be parsed. We can send these XML files from one system to another or one device to another device, can be used in communication and to transfer the data. Okay, XML has a problem of space, because you can see that it is not system defined. The tags what we are using is user defined: car, make, registration. You can make any. You can also make, for example, record of a student. So you write a student, then you write a student ID, student name, and so on. Okay, so it's easy to record. So the tag names here or the elements are defined by the users. So there might be a problem of namespace here. Okay, similar name can be used for different purpose. Okay, so in that case you need to define some schema to follow that strict and qualified names, okay, with its associated meaning in the XML definition file. Okay, so this is what we have here. So as a summary, in representing the data, we can represent the data in a suitable form, the structured data, for example, in a form of tables, in a form of documents, okay, using markup languages like HTML, XML. Okay, so what will have the data? Data can be any fact, or that is the real fact that can be recorded. It can be numbers, it can be names, it can be any other data type. Okay, so we represent the data, the real world data. We are going to shift it to the systems we see on the systems, and that will be stored in the systems. For example, the tables what we see on the screen will be stored in the system in a form of index file or in a form of arrays. Similarly, we can represent the data, the same tables on the web pages. We can also use HTML, we can use XML. By using XML, it is easy for us to share the data, also to exchange the data, okay, in the form of XML files. So the next is about transporting the data, that is sharing the data. What technologies can we capture data for transfer? Okay, so we can use XML. As I said previously, that XML is a popular as a message passing format in the web services. So using XML, we can send the data and we can receive the data. Also, we can use CSV values, comma separated values, or the spreadsheets like Excel files. We can use JSON, JavaScript object notation, right? These are the different formats, okay, of the files which we can use to transport the data or to exchange the data in a database. Okay, so in a system, in communication, fine. The CSV file, how the CSV file will be, you can see this is in a form of table, right? Data from a car dealership which has a date, registration number, customer name, customer address, postcode, what, how much he paid. Okay, now in CSV values, the rows are separated by link breaks, fields are separated by commas. Okay, and each line contains same number of fields in the same order. So in CSV, the first row in CSV will be the first value, comma, the second value, comma, the third value, comma, the fourth value, comma, the fifth value, comma, the sixth value. Okay, but there is a problem here. When we are using comma separated values, so we see one value, comma, another value, third value. Now you see fifth value, sorry, the fourth value, 15, comma, Acacia Avenue, comma, Leicester, comma, UK. Now here these comma separated, these are one single value. It's not different values, but comma separated will be one single value, right? So in that case, there is a problem here, that we don't understand whether this comma separating this value with this, or it is one value together. Okay, so in that case, it will lose the semantic information. That is, its meaning is lost. Right. So in that case, what we can do is that we can have a header row like this for the CSV file. So the first data is date. Okay, the second data is registration number, then the customer name, then the customer address. So this is all the customer address here. then the postcode, then the price. Okay, in this format we can put it. Okay, so use of double quotes. Another problem here is use of double quotes. Fine. So if you put the double quotes, for example, from here to here, it will be considered as one value or multiple values. Okay, so because usually in the strings we put the double quotes. Okay, so in that case, if you are using the double quotes, you can do one thing is that use more than one double quotes. Okay, for example, the one double quote, okay, to represent the value, the other double quotes to represent that this data is quoted. Okay, this data is quoted. Fine. So this is how we can represent the data. So in a CS comma separated values. Okay. So CSV dialect differences different in line terminators. Okay, different CSV will have a different line terminator. The final line of the file may not be employ the line terminator. Leading and trailing white spaces may not be ignored. Different separator character for header rows. Different escaping characters. Okay, same dialect will always quote every field. So these are some dialects that is to be used in CSV file. So common separated value file, these are another way to represent the data. So we can describe the CSV data format. Okay, so what will be the line terminator, for example? Quote will be how quote will be represented, delimiter, how it will be represented, comma. Okay, the initial space is false. So this is just describing the format of CSV. This is called CSV DDF. Okay, which is CSV dialect description format. Okay, so use this dialect description format for any files, so that file will follow these rules. What will be the delimiter, what will be the double quotes, will they use double quotes or not, what will be the line terminator, how to quote a characters. Okay, these are all specified here. Okay. So, okay, the next representation format, JSON format. Okay, till now we have seen the representation format in XML, in CSV file. Now in JSON format, it is an object format. This will have the data is represented in a form of attribute value. Attribute to value. Every attribute will have its value. Okay, and the objects are enclosed in the curly brackets. Objects are enclosed in the curly brackets. So you see that every object, for example, every attribute, width will have the value 800, height 600, title view from 15th floor. Similarly, thumbnail is an attribute. Its value is a set of values here: URL, height, and width. Okay, so the JSON represents the data in a form of attribute to value, and the JSON objects are created by using curly brackets. Okay, and in JSON can also support the arrays or set of values by using square brackets. By using square bracket, fine. So like this, data can be represented in a JSON form, in a JavaScript object notation form, JSON file. Okay, this is also an structured data. So this is a JSON form, and its equivalent XML is this one. Okay, so we have the image, the whole object starts from here, ends here. So the first attribute is image, so we'll have that image tag here, start of this image, end of the image. So everything comes under the image, right? So we have width, under the image we have width and height, title. Okay, so we have width, height, title, then we have thumbnail. Thumbnail, start of the thumbnail, end of the thumbnail, and inside the thumbnail what we have URL, height, and width. Okay, so here is the start and here is the end. So inside the thumbnail we'll put these values: URL, height, and width. Then after thumbnail we have animated, then we have IDs. So animated is here, walls, IDs, we have 4 different IDs and close of IDs, and that is the end of the data, so we close that image. So this is in a form of, this one is in a form of what? In a form of XML. The same is this in a form of JSON. Okay, so that's about the representation. So we can represent this data to exchange or to transport the data from one system to another system by using XML, by using CSV files, by using JSON. Three ways we can send the data from one system to another system, or we can exchange the data. Okay. Okay. The next topic here is Open Refine. Okay, what is an Open Refine? Open Refine is a tool for previewing and cleaning data sets. Okay, it can import and preview the CSV files, Excel files, XML files, and data files. It can load data from local files or from the web servers, from the URLs, and cut and paste text directly. Okay, so using Open Refine, you can view the data in a form of CSV. Okay, I can preview the data in a CSV files, data in Excel files, data in XML files, data in a JSON files. Okay, so JSON and CSV together, most significant problem with the CSV is the semantics. Okay, how the data is defined, what is the meaning of the data. So you need to define some data description form for the CSV, and also there is no requirement that column headers are specified within a CSV files, and no clear conventionally encoded way of describing either data type or any other metadata in CSV files. In CSV files, we cannot even specify the data type or metadata. Okay. JSON is more clear compared to CSV. JSON uses attribute value format. Okay, for every attribute there is a value. Fine, the value can be of different type. So, for example, you see that JSON, the JSON form for name, title, okay, and other fields. So it's very clear. We can read it very easily and say that okay, this is in a some more better form compared to the CSV. Okay. Similarly, you can see that JSON creates these objects. Fine. So we can see that how the columns in a table are held together in a list structure. Okay. We can create a JSON from the table. Okay. For the tabular data, we can have the JSON. We can have the CSV. But JSON is more compatible. Okay, and it can hold data as well as the metadata. Okay, compared to the CSVs. Now, checking the validity of the data, you can check whether a text file is a valid JSON file or not by using JSON lint service. Similarly, CSV files and CSV qualified files with a schema description based on JSON table schema can also be checked for their validity by using CSV lint service. Okay, so we can check the validity by using these services in CSV lint service. Okay. Other data representation and packaging conventions, we can use XLS, that is a spreadsheet, XML files. We can use DBMS, okay, that is a standard way to store the data. By using XML statements, we can create the databases and we can create the tables, and then we can store the data inside the tables, right? Okay, so this is all what we have here for you in this part 2. Fine. So as a summary, in part 2, we're talking about acquiring the data. So how we acquire the data? First thing is that we understand what is the data. So data are nothing but the numbers, the real world fact that can be recorded. So different type of data. The type of data can be of any type. It can be numbers, it can be in the form of text, characters, okay, alphanumeric, fine. So we can use data types to define the type of the data. Then we see that how we can represent the data. Data can be represented, the structured data can be represented in a form of tables, in a form of documents. Okay, in representing in a form of tables, we can draw the tables. Every table will have rows and columns. Okay, every column represent an attribute of one particular row. I mean, the attribute of the rows. Okay, so every row represent one particular object, fine, and every column will have the same values, and it has the table will have can store both data as well as the metadata. We can also present the data in a web page by using HTML. Okay, using HTML, and then we can also present the data, the structured data in a form of documents. So every document will have that headings, titles, headings, subheadings, then paragraph. Okay, so that can also be that can also be represented by using HTML language, right? By using a markup language. Then we talk about transporting the data, how we can transfer the data from one place to another or from one system to another. In transporting the data, we have seen the XML. Okay, XML can be used to transport the data. So XML is again a markup language. It is in user-defined markup language. User define its own tags or the elements to store the data in an XML file. We also saw in transporting the data in terms of files, the CSV file, the comma separated files, but the comma separated value CSV files has a problem of semantics. Okay, so we need to define that. We need to give the definition format for the CSV files before we create the CSV file to solve the problem of semantics. Then we talk about JSON, JavaScript object notation, that is uses that creates the objects of the data, fine. So it uses curly brackets to create the objects, and inside the object it is store the data in a form of attribute value. Okay, every attribute and its value. And we have seen that we can create from a JSON file can be converted into XML, XML can be JSON, and similarly from XML to table format to JSON. These are all possible, fine, and these can be used to transport the data, can be used to transport the data. Now to display the data and present the data and clean the data, you can use the tool called OpenRefine. OpenRefine tools can be used to display, to preview the data in a form of XML, data in a form of CSV, data in a form of JSON, fine, or are there any other format can be previewed by using OpenRefine. Okay, so this is all what we have here for you in this part 2, acquisition of data pipeline. So in part 3, inshallah, we'll talk about the presentation of the data after the acquisition and presentation. Then we talk about clean analysis of the data. Now this part also has some activities like part 1. So please do the activities here. These are all self-explanatory activities. So just do the activities. This activity talking about the data types, okay, how the data can be stored, data file formats. This activity, it uses the notebook data file formats, fine. So this activity is talking about a table format. Okay, a table must have one or more columns, the order in which it is significant, a list of rows, order of which is significant. A table cell with a particular table associated with a particular row and a particular column. Okay, so this is talking about the tables, fine, and this is a practical activity. So it's also this one is talking about the CSV files. Okay, and this is also talking about CSV files, problems with the CSV. Now this activity is talking about JSON. Okay, this is an activity of the note from the notebook. Okay, so please do this notebook 2.0 2.2.2 data file format JSON. Okay, So there you can see the JSON format files. This is also in practical activity. 2.2.3 are other formats of the data. So these are activities, these are exercises. Okay. So with activities and exercises, you get a hold on what we learned in part 2. So I recommend, I just recommend here to do the activities of part 1 and part 2 after installing the software. I hope that you try to download that software, the course software, and watch that video on how to run that course software, how to run the notebooks, and please do run the notebooks. Running the notebooks and doing these activities are very important. So do the part 1 before the next week. You should be completing the part 1 activities and part 2 activities, the notebooks of part 1 and part 2. This is very important. Okay, so you learn a lot from the notebooks. Okay, what you learn here, you just make it strong there while you do the notebooks. Fine. So this is all what we have here for part 1 and part 2. So inshallah in next class we will take part 3 and 4. So I'll stop here for today. If you have any questions you can ask. Okay.